Okay, here's a couple examples that you asked me about. So you got the line of best fit correct, meaning that you put all this data in Rossman Chance, you got the correct regression line, and you got the slope correct. So it says, what does the equation predict? This is the equation. Here's that equation to predict number of hours the phone will last. That's your Y value. It's going to predict that given you put in a brightness level, in this case of 99. What you did was you looked at the actual value from the table. This is your data that you observed, or that you actually saw, your actual data. The line is going to predict what the Y value is, the brightness level, when you put in a value of X. So if you take your line, this is your estimated 7.57 minus, now we put in for X, in this case equals 99, and we solve, we get 1.9 hours. So you were just pulling it from the table. That's the first one. Second one here, I think you just reversed the order of calculating the residual. So you've got your estimated line, y hat, equals 64.68 minus 0.62x. And it says, what is the residual for the observation? Here's my actual observation. When x equals 82.9, poverty rate, or y equals 15.52. This is my actual. If I looked at the table here, 82.9, it's probably like right here, 15. That's the actual dot when high school graduation rate is 89 or 82.9, poverty rate is 15.282. That's my Y value. What does the line predict? Now I'm going to take that same X value and I'm going to substitute it in and come up with the predicted Y value, which is 13.282. Residual is actual observed minus predicted. So you must have just flipped it around because you got -2. So that's what that is. And let's look at this last one here. So you've got the correct line of best fit. So you put all that into Rossman Chance. All good there. You got the slope correct. Here, again, let's see, what did you do here? 91. Yeah, I'm not sure what you did here, actually. So again, this wants to know, what does the equation predict? That means you're going to use the linear regression equation. It wants to know, what are the number of hours? Hours is Y, so it wants to know what is Y equal to when you have your brightness level X equal 91. So you're going to use your equation that you got right here, and you're just going to substitute 91 in for X. 6.45 minus 0.049 times 91 gives you 2.8. So yeah, I'm not really sure what you did here. I don't know, maybe you just rounded it. The 4.6, I'm not sure. All right, and so then the residual again is just my actual Y minus what the line predicted for Y. All right, well, here's my actual. All right, so when my brightness is 91, I actually saw 4.6 for my Y value. That's my actual. What did the line predict? My Y hat? Well, I just predicted it here, 2.8. The difference between the two is 1.8 hours.